All right, good morning or good afternoon, everyone. My name is Adlan Fela. I'm pleased to present today's webinar, The Road to Wi-Fi 7. We have an exciting panel of speakers here. So I'll be your moderator. Today, I'm a senior analyst at Maravedis. We have the privilege to have with us Dorothy Stanley, who's the group chairwoman for the IEEE 802.11 standardization work group. She's also an HPE fellow. And following her presentation, we'll hear from Gavin Newman, the director and engineering architect at Curio. So the program today is one where we will be looking at the milestones, the roadmap for what to expect in terms of standardization for the 802.11be. Call it Wi-Fi 7 because it's, from a marketing perspective, easier to pronounce, but obviously we all know that the standard has a different name than the certification. This is the second webinar from a list set of webinars that we're looking at producing. The first one was around unlocking the potential for Wi-Fi with open roaming, which we had a couple of months ago. And today I'm pleased to have this webinar on Wi-Fi 7. If you're interested in other topics of interest to you, please reach out to us. We're always looking for speakers and of course partners and sponsors. Just a few words about Maravedis. We celebrated 20 years last year. The two areas we look at really are the convergence or coexistence of connectivity in Wi-Fi and private 5G and LTE in different verticals. We're currently running a survey of connectivity requirements from for smart warehouses. So the survey is still running. If you want to win a chance to win a $200 Amazon gift card, we're doing that. But obviously, we're reaching out to the very specific verticals around the logistics and warehouses. So that's running. It's pretty exciting survey because it's pretty unique in the industry. The other areas that we focus a lot on are the multi-dwellings, that includes student housing and senior living. And we also have a survey going on there, which we completed, and this will be used to produce a report that's in the final works. So what we did is reach out to the property managers, the SMP, service management providers, and ISPs to understand, their own connectivity requirements, both to manage Wi-Fi beyond bulk internet and enable facility IoT for the building. So I'd like to start today and kind of set the stage for the discussion with some survey results that we did as part of the WBA, the Wireless Broadband Alliance annual report. The WBA annual survey of Wi-Fi stakeholders always provides important indicators of the state of the market and the developments that are kind of the most important in the industry. In the 2023 edition, which was published a few months ago, the response was high. So we did ask, what Wi-Fi 6 or 6E features do you consider the most important? So those are responses from different parts of the ecosystem, 36% of which were service providers, but we also had enterprise and other parts of the ecosystem. And in terms of geographical distribution, North America and Europe were the vast majority of the respondents. So as you can see here, the most important way in which Wi-Fi impacts commercial success, as we see in the research, is more and more the need for providing quality of experience, both in the home and in the commercial area, to differentiate. So it's not surprising that the survey results indicate that OFDM, uplink, and downlink are one of the most sought features in Wi-Fi 6. And that's because the huge increase in video traffic puts new burdens on the capabilities that are required from Wi-Fi. And that need, of course, drives the need for more throughput and lower latency, and better transmission scheduling, which is also indicated here. We also see that one of the top sought features was the target wait time, which ensures the client devices can save power and extend the battery life, which is a critical advantage as homes and enterprises get more IT adoption. In the second part of the same survey, which is sort of the same question, but because of visual reasons, I split the slide in two. We can see the high interest in Wi-Fi 6E is also driven by the spectrum, the availability of additional spectrum, the 6 GHz band in many parts of the world with the 6E extension. Overall, 77% of respondents said 6 GHz spectrum was critical to their business rollout. So we'll see that will be a good segue to what Wi-Fi 7 has to offer. So as much as, in fact, Wi-Fi 6 delivers significant KPI improvements, particularly high throughput and reduced latency in crowded environments, Wi-Fi 7 is going to be designed to use all of the newly advanced bandwidth with features including 320 MHz wide channels, true multi-band, multi-radio layer, carrier aggregation, and multi-AP coordination. The goal, of course, of all this is to increase Wi-Fi determinism and enable reliable communications for those use cases. And lastly, one of the questions we ask is to the respondents is to name the 3 top areas where they expect most of the growth in traffic by vertical, and kind of relate that to monetization opportunities and technology requirements. So in terms of those B2B, the most important verticals to respondents' businesses emerge as transportation, smart cities, and hospitality. So the choice of verticals is really associated with the areas in which those respondents expect to see both a monetization opportunity as well as a growth in traffic. And so, those are areas that we can expect perhaps a more aggressive early adoption of Wi-Fi 7. So that concludes my introduction. And I would like now to pass on the presentation to Dorothy Stanley. Thank you.
Thank you very much, Elaine. Let's get the presentation up here. Can you confirm that you're seeing my screen?
Yes, we do.
Yes.
Okay, are you seeing the presentation mode?
Yes,
yeah.
You can go ahead.
Okay, great. So again, thank you everyone for coming. Thank you, Elaine, for the opportunity to present on the work that's going on and some of the work just completed in the IEEE 802.11 standards working group. I'll discuss 3 topics within the 20 minutes or so that I have here. Let me just, it's a great topic. I'll talk about it. Setting a timer for myself here. So, okay, so we'll talk about the overall evolution, some new work areas where we have some exciting work going on. And as a disclaimer, these are my comments individually, and they do not represent the position of the IEEE. Okay, did the slides advance?
Not yet.
Not yet.
Not yet. hold on.
Yes.
Yeah. That's in PowerPoint mode.
Okay. So here you can see the focus of the IEEE 802 work, which is on the Mac and Phi. So while we might look at upper layers, generally we reuse the work that's underway in the IETF. And this brings a number of benefits, including the ability to reuse and leverage the work that's ongoing in other areas without the need for bridging, et cetera. So this is a orientation slide, basically. So .11 evolution, as you know, we've continued to develop base Mac and Phi standards that have been marketed in the industry, now known by their branding names of Wi-Fi 4, 5, 6, 6E, and 7. And you see here a summary of the major features of each of the releases. Starting with Wi-Fi 4, 11N, and of course there is several prior generations of amendments before that. We have support for 2.4 and 5 gigahertz. 11N was notably the first standard that provided sufficient bandwidth so that you really could talk about a wireless only office. So that the throughput was enough to support the needs of most office applications. That was followed by 11AC Wi-Fi 5, which focused only on 5 gigahertz, but increased the channel was supported significantly from 80 to 160 megahertz. And of course, we always provide the backwards compatibility, which is critical to supporting, especially
Dorothy,
applications in the home.
Dorothy, we're
Yes?
still seeing slide 2 here.
Oh, I apologize.
Okay, very well.
Okay. All right, thank you very much. So additionally, and notably, we always support the backwards compatibility so that we can support prior generations of equipment, and that's particularly important in the home. 11AX, Wi-Fi 6 and 6E, you see the characteristics supported here. The big change here, and it was highlighted in Adlane's survey of important new features, is support of 6 gigahertz. And this is extremely critical for the evolution of Wi-Fi networks and the deployment of dense networks, of new applications, et cetera. So our thanks go to the regulators for making that spectrum available, and we encourage adoption of the full 1200 megahertz. 11BE, Wi-Fi 7, there are early products shipping now, and certification is expected at the end of the year. Here, the improvements you'll see listed here, and in Gavin's presentation later within this session, Gavin will go through the details of the features, so I'm not going to focus on those right now. Okay, so beyond Wi-Fi 5, 6, and 7, within the IEEE .11 working group, we're starting work on UHR, which is the Ultra High Reliability Study Group. This group is investigating technology beyond Wi-Fi 7 to look at continuing to improve the reliability, reduce latency, and a whole list of things here. We've started the project authorization request approval process, and the target is for the task group, which will be known as 811BN, to start work in November. So some technical discussions are underway, and again, it's an opportunity to continue to improve the technical capabilities of .11 systems. We take as a baseline the fact that we're providing longer range, higher throughput, backwards compatibility, and positioning capabilities. And we're looking at continuing to drive lower latency, improve manageability, reduce power consumption, and higher reliability. With a recent focus on the need to conserve energy, etc., the reduced power consumption portion is also quite important. We'll also be starting a new study group called Integrated Millimeter Wave that will begin in November. And this is a group looking at 60 gigahertz technology and how we might more efficiently leverage that technology using the existing base MAC and PHY that's used in the 2.45 at 6 gigahertz rather than an independent PHY. So those are new work areas that are coming. So this chart shows the, this will be a reference for people. You can look at all of the amendments under development and how they are situated in time and maturity. So from the right, we see the existing base standard, which is 802.11/2020. Since that standard has published, we have completed a number of additional amendments, and we'll look at more of the capabilities of these as we go forward in the talk. 11BB, broadcast services and light communications, these amendments have just been approved and will be published shortly. And then you see the new work items here and the existing amendments that are under development. We'll look briefly at each one of these. So looking in more detail away from the R chart, we've completed 4 amendments that were published in 2023 or recently approved, and we expect it to publish later this year. 11AZ, which focuses on positioning features. So this amendment supports improved accuracy and granularity of ranging and location positioning-based services. So from supporting a 1 to 2 meter range of accuracy, which we can do with mechanisms in the 802.11/2020 standard, we can go down to half a meter or even less, depending on the particulars of the connection. So very important for a lot of new applications and adding new features to a deployed network and bringing more and more value to customers. 11BB, I mentioned light communications, and here the idea is to leverage the existing .11 MAC and use a new PHY channel for applications where the RF environment is difficult. So again, bringing new solutions to the market for what today are underserved and difficult to serve environments. 11BC might be interesting to people who are looking at IoT applications. This is the Enhanced Broadcast Service Amendment. This provides a new capability to .11 systems, which is an uplink broadcast. Today, as you might know, broadcast is supported in the downlink only. And by adding an uplink broadcast capability, you open up the environment for applications such as client devices, very low power client devices, to simply broadcast their information that to whichever access point might be nearby in a secure channel that then could go back through the internet to a server. So if you think about applications that just need to send data periodically to a server, this amendment will be of interest. And then 11BD, we'll talk about enhancements for next generation V2X. The links are here for a webinar for more details that was given about a month ago on 11BB and 11BC, and a recent Wi-Fi Now tutorial on 11AZ. Okay, here's some details on the 11BD amendment that just completed. And for regions that make the spectrum available and via regulatory means make the 11P and 11BD solutions to be applied, this amendment supports a number of V2X use cases and adds higher throughput, longer range, and positioning mechanisms in a completely backwards compatible way. So the systems in the market are known as DSRC or 11P based, and they're deployed typically in Europe. This amendment provides new capabilities that will still enable the backwards compatibility and the deployed devices to be used. So it's a very streamlined evolution path. Okay, so those are the most recently completed amendments. Before I talk about the new amendments, I'd like to highlight one additional completed amendment, 802.11ah, which supports sub 1 gigahertz operation. And while this amendment itself was completed a while ago in 2016, implementations are just starting to come on the market. It was a new 5 for us, sub 1 gigahertz, and it's taken time to get the whole ecosystem built up, but we're starting to see products in the market now. Again, the focus being long range, so higher throughput and longer range than a lot of the other technologies that are out there. The 1 kilometer is turning out to be a conservative estimate for some of these devices. But with the sub 1 gigahertz bandwidth, you do get more robust connections and a longer range. And so this is enabling connectivity via .11 system that can serve a whole range of new use cases. I encourage people to look into this and would like to highlight this Wi-Fi certification that's available. And in Japan, there's an 11AH promotion council. They just had a big meeting a few weeks ago, and they're looking at how to leverage that technology for a number of use cases, including industrial automation. Okay, so now let's look briefly at the amendments that are under development. 11BE, you'll hear about in Gavin's presentation. 11BF is wireless LAN sensing. So this is using the .11 system in a new way to, via the characteristics of the RF signal itself, to learn information about what is in the environment. There are privacy concerns that are being addressed, but this can be used. I've seen a demo, for example, of using this to determine whether or not you have a child in a car. That there are some applications where you want to know whether someone is present. And this is another example of using a deployed network for a new application via the additional of some new protocol elements. 11BH looks at randomized MAC addresses. So as you know, privacy is a continuing concern. And so a number of years ago, there was work done where the MAC address that a device uses, particularly when it is searching for a network to connect to, is randomized. And that's been implemented now in all of the client devices and major OSs. And so what that did was break a lot of the network applications that depended on a specific MAC address being used for a particular device. So what this amendment will do is define an additional identifier, a device identifier, independent from the MAC address that can be used if the network needs a more persistent identifier, but still in a way that is authorized by the end device. 11BI looks at continuing to enhance data privacy, and then 11BK looks at extensions to the ranging and positioning mechanisms that leverage 11BE defined 320 megahertz channels. So with positioning and location, the wider the channel, the better your estimation of the particular range. So with 11BK, will be in the centimeter level range of accuracy determination. So for those applications that require it, that will be available. Okay. The next couple of slides focus on new work. So here we're looking at areas where we do not yet have a task group underway doing work, but we're starting to look at, say, is there sufficient interest within the .11 community and sufficient work required to augment the protocol to add this new functionality? And of course, AI/ML, artificial intelligence, hot new topic. What we're looking at is how can we extend or modify the .11 system to enable AI mechanisms to be used to further enhance the efficiency of operation within the Mac and Phi. So no worries about taking over the world and you know, false news or anything like that. This is very focused on .11. Can we make applications or functions like channel access control and link adaptation more efficient via analysis of the existing channel, of historical data, et cetera, so that we continue to improve the efficiency of operation. So some of the areas that we're focusing on are listed here: channel access control, et cetera, contention window sizes, channel usage, improved BSS transition. So again, the efficiency of the system itself, how can we effectively use data and analysis on that data to drive efficiencies and enhance throughput, better range, better user experience, et cetera. I encourage people to take a look at the material here that is on the website. It's quite interesting. The second topic interest group is the use of ambient power. This is now a study group, so it's not a task group yet, but it's a study group. And this is supporting ultra low power devices and indeed harvesting energy from the RF in the air to do so. Again, a very interesting area of work. We had done a lot of work with 11BA in the past for ultra low power wake up receivers, and that I expect that will be leveraged here as well. So again, link here on to a document that describes the work that has been done. I encourage folks to take a look at this. Okay. And then, so that completes the discussion of the work underway in the working group. Please contact me if you have any questions. My final remarks are on a couple of items I'd like to highlight. The first is that there's still a dramatic need for connecting the unconnected, and that .11 wireless LAN devices play a key role here. The work that's highlighted on this slide is where we have hotspot access and community Wi-Fi that are provided using the .11 systems with a variety of backhauls, including satellite and optical. The example here is an initiative between the IEEE and the Internet Society, where they're using money to extend the deployment of a program that the IEEE has developed called Building Wireless Community Networks, where local entrepreneurs are trained to on wireless networking and networking technology so that they can manage and maintain networks that are deployed in these remote environments. So this course is going to be translated in 5 additional languages to benefit the additional geographies within India. So very interesting work, again, highlighting the ubiquity of .11 systems and their benefit globally. Second to final remark, we really need the 1200 megahertz of spectrum and 6 gigahertz. So to the extent that we can give this, we can get this, we can continue to extend .11 systems at their applicability in new applications and in existing ones to provide additional capacity. So in closing, we continue in the IEEE 8211 working group to add functionality and improvements, enhancements, new technology, so that we can address new and existing use cases more efficiently, deliver economic value to consumers, and enable economic growth and societal development. With that, Adeline, that concludes my remarks, and I want to thank everyone for their attention.
Thank you, Dorothy. A lot of work, very impressive. Seems like you guys are very busy, and it also helps me get an update for the upcoming report that I'm starting to work on for the WBA. So you and I talk every year around that. We will have a Q&A at the end of the session, but I would like to address one question that's addressed to you, Dorothy, from one of the audience members, and that is, can .11bf and BK work together?
Can BF and BK work together?
Correct.
BF is sensing, yes, BF is sensing. And so it's a different technology, it's a different application. It might help if you had an application, a use case to describe on how they might be used together. But BK is really looking at extending the 11AZ protocols to the 320 megahertz channel, in addition to the 160, 80, 40 that it supports today. So it's a complementary application. If you have a use case that requires the use of both, yes, they can be used together. At the protocol level, I think there's independence, but at the application level, yes, they can be used together.
Okay, thank you. All right, so without further ado, Gavin, it's your turn.
Thank you, everybody. Dorothy, that's fascinating. I really enjoyed that. And it's going to be exciting times for us all, I think, as the special idea for definite. Okay, so my name is Gavin Newman. I'm working here presenting on behalf of Curio, the Cable Labs testing arm, and we're going to talk about the road to Wi-Fi. I think the challenge we have, and it's, you know, Wi-Fi 7 is up and coming, emerging through standard, and I think we're going to sort of talk about that in some areas, but also look at the test strategies. We're going to look at test challenges. What is Wi-Fi 7 as far as we know right now, and where Curio fits into that as well. And then there's a final reach out, which I'd like to put out into the actual space for us to talk about. So when we looked at, Dorothy listed the norms, the actual standards we've been working from Wi-Fi 4, ISO 211.n, 2008, which in Wi-Fi terms is a long, long time ago. And you look at the max buy rate, the 72,600, and as Dorothy said, that was when we started seeing some really larger throughputs that we could actually say we've got a Wi-Fi network within the premise, within the office, within sort of the actual installation, and it worked quite well. Obviously, that was the start of the huge arms race of volume and space and consumer devices and growth. And we went through AC, 2014, we went through 6 on to 2019, and obviously 6E we settled down on 2020, and actually that gave us the expansion into the 6 gig spectrum, which is great. Now, obviously Wi-Fi 7 is just another game changer, really. We're looking at throughputs which are it's quite scarily sort of 13 times faster than Wi-Fi 5 and 4.5, maybe 4.8 sort of times faster at the buy rate on 6AX. These are serious inputs of change, and actually when we go through the slides we realize that actually the focus is not high efficiency as AX Wi-Fi 6 was all about, which is about efficiency of the payload and sort of airspace. This has gone back to where Wi-Fi 5 was around, where it was HT and VHT, and we've gone to extra high throughputs. So those are key deliverables. And I think when you look at some of the deliverables that were the actual big headline takeouts, Dorothy picked up most of them in very good level of quality as such, but just to recap them on them, you know, the modulation moving to 4 QAM from 1K, it's going to have an impact. There's various numbers around forecasting 20% increase, etc. I think it's going to be interesting. I think it's going to be sort of, 20% on the nominal rate, but I think that's good put. And actually what it turns out, what it transpires out into the deliverables would be, it could be something different, but I think there's going to be a penetration range improvements on this as well as the actual sort of wider bandwidth. But, you know, are we going to see an increase in speed? Yes. On the near field effect, absolutely right. On the further effect, to be seen. And I think I'm coming from all these benefits of, well, let's see how they all work together and in isolation and make sure we actually get a feel for the technology, the design of these improvements, but also how is the end experience within our MSO customers, our OEM manufacturers, devices, and when you start adding unit feature changes together, where do the benefits actually really materialize? And that's the exciting part of Wi-Fi 7 in many ways, because there's so many areas of change. You know, and so you're looking at the channel sort of the bonding. We're talking about obviously on the 6 we talked about 320 mega channels. 160 was the old on the 50. So we've doubled that throughput as well, and we've obviously gone from spatial streams from 8 to 16. You know, yes, the conditions are going to be very sensitive to making sure those high level numbers are there, but the enablement is very, very high, and it allows us to have multi-MIMO spatial efficiency gains. In theory, double to where we were. So it's not uniform in capacity, but I think it's a very exciting thing as well. So I think, you know,
Gabby, sorry to interrupt you. Which slide are you on? Because I'm still seeing changes coming.
Yeah, that's right. I'm on the right-hand side of the slide there.
Okay, gotcha. Sorry.
There you go. Okay. So yeah, where else were you? You throw me off guard there. There's lots of unknowns, and I think and I said that there's lots of unknowns within the actual working group as well. There's lots of knowns as well. And I think with permutations, as I said, are going to be the areas where we're going to be really quite excited on there. EDCA with time-sensitive networking, good QoS improvements. Currently using AX, but actually sort of there's further improvements on Wi-Fi 7 on BE, and I think, you know, that's going to assess the lower latency demands of videos and actually give the TICTOPs opportunities, greater opportunities. I think that there's a real opportunity for the RTA applications there to increase their availability with the access categories being given there. I don't think it's going to solve world planning, but I think it's going to be a vast improvement from where we were today. One of the dilemmas of EDCA is quite clearly you're trying to manage an unmanaged spectrum, and actually that's a difficult place to be. So we've got to contain these sort of expectations a little bit. Enhance OFDMA, latency gains, clearly, you know, we could actually, sort of, if channels were idle, we could dynamically expand the TX and support them to 40 meg channels on Wi-Fi 6. It takes it to a next level on there and actually adds a little less rigidity on there with the preamble puncturing on 320 meg channels, but also allows us to take in the TICTOPs on the single frames for a single frame packet. So that is really quite interesting, and I'm looking forward to seeing how that one sort of actually materializes out there. Obviously, there's HARC improvements on there, the hybrid also request repeat, which we'll talk about in a minute. Adding to those gains, and without any shadow of a doubt within the OFDMA, is the support within Wi-Fi 7 for the multiple RUs. These plus units are sort of normally on AX, AC, there's one RU per station. Now there's multiple. That amount and allows us for the ability for multiple transmissions. The efficiency within there could be violated, I suppose, if you were to index and treat all the RUs with the same header indexes as is currently done within Wi-Fi 6. But actually, Wi-Fi 7 is quite clever on this one because they're taking on the first RU sort of headers, as it were, and actually indexing field all the associated RUs underneath that associated to the same station. So the actual packet interrogation actually looks very good. And they're also grouping those to high user yields and low user yields as well. That could be quite an interesting benefit. On its own, not sure, but when you start adding it to the other benefits, then we're starting to see some quite large changes. The one that really floats my boat is under the efficient spectral usages is the element of multi-link operation. Now, This is where we literally add a 2.4, 5 gig and 6 bandwidth channels together concurrently. So you could have a 160 meg throughput on a 5 gig or 6 gig, and with a 2.4 20 meg channel as well. And that's not only load balancing, but it's also concurrent RxTX bandwidth on the MLO as well. Now, how the NIC, the network interface cards, handle that on their drivers is going to be really, really interesting, because the way it works is your LLC layer 2 will actually have a virtual MAC address, and actually, so the radios will actually have these multiple access layers coming through, combining itself onto the LLC and up into the 7-layer protocol into a single packet data frame. That's pretty sexy, and I think that's very interesting to see how that's going to work. It's going to assist latency without a shadow of a doubt. I do worry about power consumption on there, but I think that's going to be really, really quite sort of fascinating to understand and measure. Power leakage across the bands is probably minimized, really, because we're not getting such tight just sort of band usage concurrent within the same spectrum as well. So that could be really quite interesting. And I think you've obviously got bandwidth efficiencies with TWT, which came in with Wi-Fi AX, but actually the target wake-up time has been, or snorkeling as I call it, has actually been improved as well. And I think it's going to be more widely used in Wi-Fi 7 as well. Another little one which I'm working through is the multi-link architecture, where multi-link devices can actually replicate ad hoc data networking. That looks quite interesting as well, particularly for particular areas. Draft 4 has started to work on that area, and I think I'm looking to see whether that's going to be affecting the AP installation, the actual sort of, to see whether it impacts on how the stations work together. Channel sounding optimization, more work to be done and understood around there. There's a lot of beamforming reporting on the SNRs, on each spatial streaming, how that works and how it gets integrated back into the actual layers. I've yet to get my head around that, but I think that's going to be quite an interesting one. And of course, we've got advanced 5 methods, spectrum efficiency. We talked about HARC earlier. I think this one is quite an interesting one, where HARC is the actual sort of hybrid auto repeat request. Normally, when you drop a packet, or you get a corrupted packet, it's a full retransmission. With the HARC, it has the ability to look at the checksums. If they don't marry, they can actually somehow, and this is what I'm very keen to understand, is actually see how it asks for retransmission, but only of the missing elements of that. And it will sort of narrow it right down, so that actually the payload and therefore the traffic usage is much more effective. That's really interesting. And I think that I'm very keen to see how that impacts on more distant clients and noisy interference networks as well. And of course, the advanced 5 methods, we've got full duplex, we've got the MLO, the spatial stream combination. I think this is all going to be a very big impacting area. And the last of the impacting area from what I've sort of seen so far is the majority said on the advanced multi-AP coordination, there's a big shift away from interference avoidance now to actual cooperation. And actually, AX is a springboard for this, and Wi-Fi 7 is just making it sort of much more enhanced. Big deployments, if you imagine in the corporate sort of world, the offices, venues, sports stadiums, etc., often use Meraki to control all the APs, so there's a seamless experience when you roam around the office or you roam around the stadium, etc. These are off-the-shelf packages that run and control multiple APs and have their own logic. Wi-Fi 7 is looking at that backhaul multi-AP messaging on their own private network and how that handover works much more effectively. Looks really interesting. There's particularly in certain niches such as corporates. But actually, there's another one as well as part of that where we could actually see station beamforming null beaming, right? Which is actually where one AP sees a noisy interferer on its network and actually will nullify and actually sort of steer it to that station away from its network. How that actually materializes, I look really forward to it, because that could actually cause a lot of impact on our multiple dwelling installations, the MDUs, blocks of flats, etc. When there's the interference levels from multiple APs could actually be very, very good. Again, it may well need sort of inter-ISP standardization on there, but that's quite an interesting one. And of course, multi-AP coordination really gives you that Wi-Fi roaming perfection. It's getting to be a game changer as such. So that could be very, very interesting in sort of methodology. I'm not sure how it's being deployed yet. There's various ways around of sounding, nod steering, joint alignment, I guess, coordinated OFDMA, and maybe even through the actual CSR, the conditional or coordinated spatial reuse. I'm not sure yet. More work to be understood on there. And of course, Wi-Fi 7 is still work in progress. Going to the next slide, I just wanted to look at the advantages, a little bit of a summary of where we were in some ways. Dorothy rightly said that 6 gig, 320 mega channels, that's a huge improvement. The full QAM throughput, 20% increase, we discussed that, it's really good. MLO, huge amount of permutations, particularly with the RxTX concurrency, and what's possible and what's not possible. And I think that's really, really interesting. And the area around SLO, as in the single line operation and multi-line operation, with the simultaneous transmission reception on the spatial streams, those areas are looking very, very interesting. Obviously, I think as a byproduct, all these areas are going to have an impact on latency. I think and that's the key objective of Wi-Fi 7. I think there's going to be a better improvements on TXRX range. We saw it with AX versus AC, quite marked improvements in many ways. And I think obviously we just talked about the AP configuration, coordination rather. And I think the concurrency on the TXRX is going to be quite exciting as well. We look at combined, I mean, I'm very keen on the user experience of Wi-Fi because we can all put all these technology solutions together and it's great. But actually, if the customers don't see any benefit, they're just not going to buy it, or they're going to end up with our multi-service operators having disgruntled customers and they won't want to buy any more technology. So we've really got to be sort of making sure that our benefits really do shape the tree and deliver what customers want. And, when you look at sort of Wi-Fi 7, it was about high throughput and the focus on the design was high throughput and improved user experience. And I think when you look at the marketplace, gaming, real-time applications, and the concurrency growth of those real-time applications, and of course IoT focus, which is yet to really explode, but it's on its way. AX had criticism that it didn't address more horsepower, and I think Wi-Fi 7 has come around the corner really addressed that, as we saw on the headline numbers, and that was the plan. And I think when you look at Wi-Fi 7 combined with Wi-Fi 6, actually we're starting to get into a very mature Wi-Fi solution, which is going to last us a while in some ways. And you look at the timelines between 802.11n, 2008, and to where we are now, it's been quite a while. And so these technologies do take the time to actually mature. And I think Dorothy put up a slide where sort of actually when standards are ratified to when we see proper mass products into the marketplace, it's circa 2 years, I think it is. And I think that really does sort of affect it and sort of put it into context. I think the other side of Wi-Fi 7 as well is the support for IoT, particularly on the short frame transmission impact. Wi-Fi, if you look at IoT, they can actually take a 20 meg channel and transmit very short chunky bits of data very infrequently. But actually, Wi-Fi 7 actually said, well, we're going to take that away and put it into preamble checking and use that puncturing to give that channel over to someone else temporarily. And actually, the IoT device won't even know about it. So that's really quite canny and really good spatial awareness. So some really interesting things there. And of course, looking at battery life is the nirvana for everyone as such, but that and the advantage, the increase of battery technology will actually help us an awful lot. We talked about testing challenges, and I think the first one, Dorothy, we had to check last night in case I was right, but I found out yesterday that Wi-Fi 7 application was going to be, the final amendments is May 2024 release. It's now shifted back into the final phases of Q4 2024. So we're looking at final sign-off on December 24. Whether it's brought forward or not, I'm not sure. Actually, having seen some of the agendas with the actual sort of working group BE or TGBE, is actually there's quite a lot of things which they're still working on right now. The risk of change is there. And actually, that's why some of my presentation is not quite in the granular detail that I would like. But actually, because it's still evolving and things are still being discussed about the best way of adopting various coverages. But I think that the candidate list of what we've gone through is pretty accurate. I think sort of quite satisfied on there. So when you look at testing challenges, I think when you look at test equipment, as we said, it's work in progress. Right now, the market's maturing. It's the big four, big five, hardware, technical manufacturers. I'm not going to name names. We all know who we've got in our labs, etc. Have got product in the market. Of course, as evolution changes, those products we've updated via software. I think they've got hardware sorted already. Others are in development, which is great, and I think early adopters are very much in the market. I think when we look at the test devices in the marketplace, I think TP-Link, we've got a Deco. What is it? It's a BE85, which is just launched. It's not cheap, and it's Wi-Fi 7 compliant, but again, it's going to be at best efforts. Asus has just launched a product as well. These are premium units and actually designed for prosumer and sort of the early adopters as well. They're not cheap, they're early adopters, they're cutting edge, but actually in that marketplace we operate at, that's where the actual opportunities lie. Curio, when we look at Wi-Fi 7, it really says to us, it's just the same as AC, it's AX, it's got more challenges, more features, but we treat it as the same assessment as we do for all our testing opportunities. Where do we see the most important elements that our customers want us to look at, and we focus on those. And we're buying the most suitable test equipment and making those test harnesses needed, that are needed to support really the standard, but also what our customers want. And that's not only in the technical lab, but it's also in the empirical technical lab as well. So free space testing is very important, and that's why Curio's invested heavily into that test house. So test strategies, I think difficult one there in some ways. We're looking obviously what we do with Wi-Fi 6 and the Delta's Wi-Fi 7. That's a really key thing. We're building a platform which is going to be flexible. It's got to be compatible with as backwardly as we can be. I think we need to leverage the customer experience, the customer impacting issues. That's why my call to arms later will fit into this with additional technologies. And I think we've got to have the testing objectives, and we've got to look at the deltas between AX and BE, and we've got to focus on our customer base, as I said, and prioritize the right things in the right phase, in the first phase, really. And of course, when we build it, we'll test line it, we'll baseline those labs, and we're not too sure how we're going to be sharing those reports, but I think there's going to be some quite good opportunities for all of us to actually learn together on that. And I think that's really a key element. There's going to be lots of learning on there. And I think, the seamless connectivity between 5G, Wi-Fi 7, I think that's an area we're going to be very keen on. The documentation, the mass production of it. I said we focus on the two elements really around technical testing and the user experience testing. And actually, sometimes they're both two of the same one, but also the proof of reality. And as I said, when we opened up the extra slide deck of what unit tests within each of these deliverables has, but also what it's like when it's add feature A and feature B to make feature C, and what the customer experience is. And that's not only at the clinical level, the technical level, but it's also at the customer empirical level as well. Those are really great opportunities, and I think that's where we see the opportunities with Wi-Fi 7. That's something very exciting. So lost my mouse, which is great.
If you could maybe wrap up so we can have at least 5 minutes for questions. Thank you.
Yeah, I think the elements of why choose Curio for this is because we're investing heavily. We're treating Wi-Fi 7 as a great opportunity, and it's what you expect us to do. We're leading the way forward with it. We've got a great product development mindset. We've got a great focus on delivering what customers want. We really focus on learn when to and perfect many. We also know that about budget control, the new product development phasing, and actually the neutrality and confidentiality of Curio makes us a perfect partner in there. And the last element of this is I really want to just make sure everyone's on the same page when we say change is coming. It's a very clear message. It's going to impact Wi-Fi today. It's going to heavily impact Wi-Fi tomorrow. It's going to open up whole new opportunities. And I think it's going to force a lot of change within many operators and the MSOs, and also products that they use today as well. And I'd raise and leave you with a simple question of how do you think it's going to impact your role and your company? And where do you think Curio can actually help you? I'm all ears. I'm going to reach out to many of you on this conference call for some good wise words from you about where you see your needs of Wi-Fi 7R and how we can incorporate that into the Curio roadmap. And I'd like to leave you with that. Thank you very much, everyone.
Thank you, Gavin. I know that you had to rush through the end. There's a lot of stuff in there, but just that to keep this within the hour, we're going to move quickly to questions. So I have a question for you. You can stop sharing your screen, by the way, Gavin. Dorothy, a question that it's coming from different shapes and form, but it's all around what is your view. I know you're not representing the IEEE official view, but your view about conversions or collaboration with VGPP roadmap and AMT 2030 in light of the emergence of private cellular and so on. Sorry, you're on mute. Dorothy, you're on mute. There you go.
Great question. There's a lot packed in that question. So to answer it briefly, within .11, our focus is to continue to expand the capabilities of our system so that we at a MAC and PHY level are equivalent to the MAC and PHY level capabilities required for a cellular system for the use cases that apply to us. So for example, as was done in 5G and IMT 2020, you had hotspot use cases, you had dense urban use cases. So particularly for those, they had performance objectives, and we confirmed via simulation and analytical means that the .11 MAC and PHY for 11AX met those requirements. So our intent would be that whatever the requirements that are set for a 2030 target, that we would have a MAC and PHY that would meet those requirements for the particular use cases that are applicable. For example, going down the road at 200 kilometers an hour is not an applicable use case. So we would not focus on that, but on the ones that are lower mobility and dense deployments, those we would focus on.
Thank you, Dorothy. I know this is a complex question with multiple dimensions, but it's one that's always going to come back. So another one for you, Dorothy, and that's gentleman that's asking whether multi-AP coordination is really going to be included in Wi-Fi 7, or is it going to stick to Wi-Fi 8?
Right. So the answer there is there was a lot of discussion about AP coordination in the development of 11BE. However, there was not consensus to add that feature to the standard. So it is deferred. It will be, so it's out there. It'll be considered as part of 11BN Wi-Fi 8. It's one of the candidates. Again, it will continue to be discussed, but it's not in 11BE.
Okay. So maybe to finish off, by the way, this webinar is being recorded and the slide deck will be available in the next 24 hours. Should have mentioned that at the beginning. And the webinar is 60 minutes, it's not 80 minutes as some may have seen. So we'll be wrapping up with this last question, maybe to Gavin. What do you see the Wi-Fi 7 impact on new testing requirements? I know you have touched on some of the complexity of the new ones, but why should people, be concerned about in terms of testing Wi-Fi 7?
Yes, good question. Bit open-ended in reality. Wi-Fi testing generally is, you can spend millions. I have spent millions in my past lives testing Wi-Fi, and actually you've got to be effective and efficient with it. I think the elements of you need, I think you need to evaluate what you're trying to achieve. It's going to be, I think, if you test everything, we're going to spend a lot of money doing it. I think there's going to be a lot of assumption, and I think there needs to be a lot of shared data and reports come out from various trade bodies about how certain functions work. I think the MSOs are going to be picking and choosing what's important to them and how they implement Wi-Fi 7, because don't forget, it's up to them what they actually implement into the customer base and to what the OEMs create. And I think then you look at the impacts between Wi-Fi 7 and Wi-Fi 6AX, and work out what is going to be the new product development deltas, and actually work out the business case. I could easily put a number to it, but it'd be wrong, and I think every case is going to be different. But if you think you're going to implement Wi-Fi 7, even without AP coordination, which I'm gutted at because I spent a bit of time researching that, it's going to be, it's going to impact, it's going to cost, and it's going to cost in terms of you either risk it and hope it all works, which is fine, or you cherry pick and hope you get the right thing. But I think the message I would say is, I think we need to be thinking better as an industry and share our test data wiser, so we don't have to everybody retest everything individually. I think that would be silly, because the level of changes we're putting in are pretty high, and I think we need to be a bit careful on that. So I think the impact's high, but I think there are ways to negate it.
Thank you. Just to finish off then, just a reminder of the areas that we cover: Wi-Fi, private cellular, home, and all of the encompassing monetization strategies and telco cloud implementation and convergence. We provide lead generation webinars like this one, where we had over 230 registrations. White papers, content marketing, and online research is something that we're putting a lot of effort on, and business introduction. So with that said, I want to thank our speakers for the amazing insights that put together and presented today. I want to thank the audience for sticking around for the webinar, and we'll be sending the materials in the next 4 hours. I'm sorry, next 24 hours, and stay tuned for the next webinar. Thank you.